um, yeah. So let's go over. So what we're gonna so there are a few students still and some didn't attend. But anyway, so the way we do is right. We solve a problem on the current day, and the next day I'm going to solve it in front of everyone, right? So in a discussion, right? So we're gonna do that way, right? So let's go to the problem that we solved the other day. This one. So you guys did in pairs, right? I know pretty much like almost all of you did that, but I'm going to again show you because that's the way we done the last week. Okay. So, all right. It will take about like 10 minutes to do both. I'll show you both. I think we didn't do the next one, so we'll do it today actually. Okay. So, um, so problem asks to run this, try this code. Okay. So it's just don't worry about this code, and then like I said, Tuesday you will be able to write your own code like this by week 11. Okay? So just for now, click the run button, and it draws a fish, right? Okay, so and then you have to download it. So this is the download button, but before that you have to save it, right? And you are told to save as either new revision or new file. Do not click override. Okay, so I'm gonna pick new file. Okay. And then click OK. All of these instructions are here. Okay, so all of those what I'm saying right now is written over there. Okay, so when we download this code, that's for later. Okay, not now. Okay, so all right. So next step, right? So copy paste the code. So this code. So if you use Windows, you guys can follow me now if you haven't done this yet. Okay. All right. So if you use Windows, it's Control A to select all. If it's a MacBook, Command A. Okay. And then Control C or Command C to copy. And then you go here and then reply, right? And we're gonna repeat this again, guys, today. So you will get used to this as you go along. Okay. So paste, okay. And then again Control A because this is still in text mode. We want to see them in like code appearing mode. That means pre-formatted. So Control A to select all and go over here in this drop down. Okay. And then click on pre-formatted. Okay. All right. So now it's kind of appearing like code. So we go down over here and go to HTML mode by, so this is still in text mode, right? So you can toggle to HTML mode by clicking this icon. Okay. So that's that. And now this is HTML. Okay. So, and we go to the end and then we go up again and then copy that template code that I have given to you. It's right here. Okay. So this one and Control C to copy and come back. Sorry, go down and then basically paste it. And then we go over here and then take this URL because this your own. So this is basically individual student get their own one when they save, right? And then basically go back here and replace this part right here. This SRC, see that this SRC tag. So it basically go in this quotation and then basically replace that part with the link. So that is the website we are actually embedded. Okay. All right. And then when you toggle back by clicking this, it will go back to, we will go back to test mode and I will see the website is now embedded. Okay. All right. If you go back again, you go to HTML mode, and then you can, if you want, you can make edits and things. Right. And so basically that's it. This entire submission, entire solution, that entire steps that I asked. So basically, apply. That's your submission. All right. So basically the reason is, we basically write code in this class as teams, as pairs, right? And then in the end we actually embed both text, submit that code in both text mode as well as embedded mode. So two modes, text mode as well as embedded mode. So we submit in both modes so that we can run our code from the same canvas page. So that's the idea. Okay? All right, so that's done. The next one we're gonna do all of us together if you haven't done yet. The previous class we did it on Tuesday. But this class we didn't have. Remember we ran out of time, right? So let's do it now. Remember we downloaded our code, right? So we're gonna go over here. Sorry, see that this one? How to submit a file to an assignment, right click on it. So let's do this one together, okay? Are you ready? So those who have done this one, you are good, okay? But if you have yet done this one, then you can follow me and we can do it together, okay? Right, ready? All right. Okay, so I think can you help us? Yeah. Who is new today? Who is new? You are new, right? And you are new. But I see that you read that, right? Is that yours? Oh, okay. But did you do the previous one? Okay. All right. So you can now follow me and let's do it together, guys. Okay. It's good to get this done together right now. Okay. All right. Yes. Yeah. Yes. Yeah. Yeah. Thank you for reminding me. Yeah. I started. Yeah. So I posted the also the recording YouTube video yesterday. I can show you where it is actually. All right. So I'm gonna do this as a student. All right. So especially for midterm, you will follow this format. Some of the this week assignment also, you will follow this way of submitting the solution. Okay. So click on start assignment. So that's why actually we have this one as a practice. Start assignment. And then this is a file submission assignment. So you have to pick the file from your computer. Remember, I just downloaded the file, right? So by default, it goes to download folder. So you go to download folder, right? And then this is the file I just downloaded. So I'm going to click on that and open it, right? And you can see that that file is now attached. If you have multiple files, you can do so by clicking again, attaching another file. But this is another, just one file, right? You submit. That's it. And that's a rubric as well, right? If the file is missing, then you'll not get the points. Okay. So submit. That's it. All right. You don't have to, yeah, yeah. So this is just uploading the file. Yeah. Because midterm you will be actually uploading a file, and then there's a couple of assignments, including this week assignment. You will be uploading a file. Okay. So this one for practice for that. All right. And if let's say you are re-attempting, because we have unlimited attempts for assignment, let's say you are making a correction and resubmitting, press on new attempt and then resubmit. No, you just say that you uploaded and submitted the file.
But like, let's say I just had uploaded any file. Would it be like, hey, that's not the right answer. That's some random stuff.
I think yeah. See that the file types.
Yeah.
It's .py, it's a Python file.
Okay.
So if it is
So
not,
any Python file would have filled the requirements
yes,
for that.
yes. Okay. But again, when I get, I want to see the content correct continues. Okay. So I'm gonna come back from student mode. All right, guys. So we are done. So we are ready to do today's work. All right. All right. So I'm gonna go to SciBook. So we were over here, I think. Before we start, any questions?
How do you pronounce your last name?
Wali Muni?
Wally.
Wali Muni.
Wally.
Wali Muni, yeah.
Wally.
I have you heard Wali, right? Like,
Yeah.
Wali, the film.
Yeah.
So Wali Muni. Wali Muni, yeah.
Wally.
So if you want to remember, like it's a good metaphor is you have Wali from the film, and then we have Munis here, right? So Wali Muni.
My friend's
All right.
name was Kowalji Singh, and every time I said his name, he was like, "Hey, you said it right!" Like he was so stoked on it.
All right. So guys, we were over here, right? So right here, right? So we discussed computational thinking as to solve a problem using the computer or using a program, right? So that's the skill that we want to earn from this class is one major skill is actually computational thinking. All right. So and if you take this, read this problem, and you see that it's actually says turtle graphic, right? See right here,
Yeah.
turtle graphics, like turtle, robotic turtle, right? Right. So that's the same thing like this. This is also turtle graphics.
Okay.
See that you if you see if you read it like turtle mode, right?
Okay.
So basically, what turtle graphic is basically it's a module, it's a library from Python designed to teach Python. Why? Because when we see what we do visually, provide a visual learning environment, right? So we are seeing like while here you see it's actually drawing a fish, right? So you will see what you code. That's actually a really good learning environment. Yes.
What is Python used for?
Well, you're gonna learn about that too in the class, but it's actually right now data science is one big tool. Python is one big tool. We use actually Python to code in data science, not just data science, in machine learning as well. So it also one of the best prototyping language. You know, prototyping means like before we make the product, we make the prototype. So, for example, we can easily code in Python solutions, but we need more faster code. For example, like let's say C++, we first code it in Python, and then there are translators, and then I use the translator to get the code in C++.
Yeah, because I heard that C++
Many people, not there are many languages by the way, Java, C, those are like even Python. There are mainstream languages, but Python runs a little slower than those. If you need speed, like for example, programming a game engine like something like that, then you need C++. But C++ has a complex syntax, right? Python has a simple syntax, so you can solve first the problem using Python. Now the problem is solved, right? And then so it's a prototyping language. And we have nowadays we have translators.
So the translator is automated.
Yeah, yeah. So you basically feed the code to translate, and it gives you.
I was
Yeah.
thinking, is turtle mode, is that always going to be showing you like animations of stuff?
Yes, turtle mode shows you what you want to do and what to write in animated mode. All All right. Any other questions? All right. So this activity inside will introduces you to that the concept of the turtle. Okay. So basically, think of this turtle as a turtle attached, basically with the tail attached a pin to the turtle. So um, there's a pin attached to the turtle, and then if the pin is down, now the pin is hitting the whatever the surface that the turtle is on. So as the turtle moves, it draws, right? So that's what we did, right? So we actually asked the turtle to move in a particular way, and it's actually have drawn this nice pattern, right? The fish, right? So that's what the turtle did. Yes.
So is that angle because in the test on the other page, it only gives us like turn left and turn right?
Yeah, this is more complex.
You put like a mathematical
Yes, but don't worry too much about those. Yeah. So this is more a little bit more complex, but I guarantee you will be able to draw this by week 11. Okay.
because
All
I
right,
was trying to draw a star on the other one and I couldn't get it done.
that's fine.
I got
Yeah.
square and I'm trying to
I mean, if you try and then kind of try to brute force and make perspective, so let's hanging there.
yeah, I got to like that and I was like,
Okay. So I mean, you can try. That's fine. That's not no issue of trying, right? Okay. So let's go back. So now, so this is actually code, set of code written in English. Okay, it's also a language, right? So it's an algorithm, right? So it's we call it algorithm or a recipe. But when you run it, right? When we run it, right? It actually draws what?
triangle.
What kind of a triangle?
Yeah.
Equilateral triangle, right? So right. So basically, so here's, I mean, you can see that start from the very beginning. You just have to put the pen down on the paper, right? Otherwise, we will not draw. So pen down, and then move forward by 100 pixels. So the unit is actually pixel, and then move forward means move into east, right? And then to draw the next, before drawing the next side, you have to turn, right? Turn by what angle? 120 degrees, because that's how we write the equilateral, draw the equilateral triangle, right? So those are that knowledge is called domain knowledge, because if you don't know what an equilateral triangle is, then you cannot write this algorithm, right? So we call that kind of knowledge is the domain knowledge, because if to solve that problem, you need that domain knowledge. Okay? So software engineers need to have domain knowledge in the domain of the problem that they are going to solve. Okay? So, all right. So all right. So now what they're asking is, okay, instead of triangle, draw. All right. So I'm gonna clear this and then remove all of these, and you guys gonna tell me what to do.
First, you gotta put the pen down.
Pen down, okay. Oh, sorry, pen down. All right. Good.
Then I'm thinking you gotta go forward. We'll call it 100.
Okay.
Now
Forward
issue.
by 100, and you can always run it and then see if it works.
That'll get you on.
All right.
So now you're turning 90 degrees.
Because
Where?
yeah, because it's a square, right? Okay. So
If you want to draw a rectangle.
yep. So turn left by 90 degrees, right?
Now run that.
Okay.
Okay.
All right. I want everyone else to join, guys. Okay. All right. So what is the next step?
Oh, I forgot to do forward. Getting that. No, forward. No, no, no.
Next step. Oh, we did that by 90. Yeah. So this is already there. Pen down is there. When we pay, when we lift the pen, then it will not drop. Yeah, forward by 100. Yeah. All right. So next step. Yeah. Not 120, 90 degrees, right? Because you are drawing a square. Okay. All right. Next step. Forward by 100. Next step. Yeah, yeah, we can run. I recommend running it in between. Yep. Making sure we are doing the yeah. So pen is always down because if you down the pen at the very top, it's always down. Yeah, you don't have to this pen down again. Yeah, yeah. Turn left by 90, and then so if we do that, and then this will still have there, but you can see that it will turn now. Yeah, and again forward by 100. Yep. All right, that's it. So we call this turtle graphic, but this is in English, guys. Okay, not Python code. So let's run it and get a square. Okay. So, so any question? Yeah, you can assume that. Yeah, I mean, don't compare like our drawing or writing because in writing, regular right? Yeah. Here with turtle graphic, it is the pen down, always
Okay.
keep the pen down.
But that does exist. Like, if I was gonna try to program something that wrote like long letters, I would need to be using that pen up. Like anywhere where, like, if I wanted to draw a pentagram, I wouldn't need a pen up for that. Just like if I draw a square, we're not gonna be drawing a square. We're not gonna draw a square with our pen up.
Yeah, so
Lift
that's
it up.
usually what we do when we do it, right? But here it's basically like this.
Well, I'm saying like if I draw a square right now, I'm just gonna go boom, 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 boom.
Yeah.
I'm not gonna be using pen up for
Oh,
that.
yeah, you're right. You're right.
So this because computers mimic human behavior.
Yeah,
So,
yeah. You're right. Okay, so all right. So
no,
you said it.
Hey, what's your name? Sean. Sean? Yeah, what's your name? Sean. Oh, shit. Nice. Oh, oh, shit. I used to get contact when I switched to started teaching kids math. Okay. Yeah, no, I got a buddy who got PhD in math. Yeah, yeah, cool. I'm in breakout right now, and it's basically sort of a review, but there's like
All right.
less like participating a lot, and it's actually really fun.
All right, so next section, guys. It's just a conceptual list of careers in computing, and you guys should read about it. Okay, and there are some questions, so don't try to answer the question without reading them. Okay, so the questions are from the readings. Okay, um, and then there are some list of again specific careers and then entry level education just for knowledge, knowing. And these are national averages, but this area we have world highest rates, right? So um, same similarly to the expenses. So
Right.
yeah. So um, we can do this one together. You guys gonna help me, okay? All right. First one. I'm gonna go like one after the other like this, and you guys need to tell me which one to drop out. Okay. All right. First one. Um, computer system analyst. Okay. This one. This one. All right. Nope.
Oh,
Yes.
I'm gonna say computer support specialist because
All right. I think that's the one. So there you go. Okay. All right. Next one. Create, design, and program software. Yeah. Software developers. Which one? Yeah. This one. Yep. Next one. Help write programs created by software developers. Um, so help write programs created by software developers. Yeah. Okay. That's right. Okay. Help organizations use computing technology to operate effectively. Which one? Yeah. System analyst.
Oh yeah.
Oh no.
It's the other
Okay.
one. No,
What is that?
computer assistant.
Computer system analyst, right? Yeah, that's the one. Okay. All right. Next one. Focus on protecting an organization computers and data security. All right. This one, right? Oops. This one. Yep. And the last one is this one. Come on, come on. Yeah, it's that
Yeah,
one.
you got it right there. Yeah.
Oh, okay, okay. Yeah. Oh, okay. All right, that's fine. All right. Let's go to this one. So I think this. I'm gonna go to the next topic, guys. Okay. All right. So this is kind of an important thing. So yeah, we solve real world problem in coding as well, right? There's an application, right? So you see out there and solutions are many, right? Um, where, right? So and then they are not perfect as well, right? So I mean, it's very hard to solve the problem from the very beginning, right? So and you can see that and it's also some solutions are really serious. Like for example, you know, autopilot program in a plane, right? And if it crashed, right? And then, the plane may crash as well, right? So that for potential, like possibility, right? So um, and sometimes mainly human write the code, right? And then it's gone to human error too, right? And then that's one of the reason, like Boeing had a lot of trouble in the past, recent past, right? That some of their software engineers made mistakes, and then that also caused to some of the plane crashes, right? So, and you can see how serious the job is, right? So it's not just like not like a silly job or like just plain coding, right? It has some responsibility. So, and then this if you play this video and then this one example there. So, they did a mistake in the automation code, and the entire 15 minutes files went at once, right? So that was kind of a scary, and also, well, the fireworks is over, right? A couple of seconds. Yeah. So yeah. So I mean, so this is a like kind of minor bug, but there were serious bugs like Boeing, and there's one example. I can also show you video later on as well. Okay? So so we call them the software bugs, and then those things are there as well. Okay? So we also want want to accept the realities of coding that we will make mistakes and we should be willing to debug or fix those mistakes. Okay. All right. Going to the next section. All right. So we talk about three things in problem solving. What are the three? Input, process, and output. Right. So every I mean this is actually correct for real world problems too, right? So um, I told you guys the plumbing example, right? So in coding also, so there's a problem from which basically the problem statement, the question of the problem we are going to solve, right? And then in the solution, if we have some input that we can use, right? And then the process basically the algorithm that we are going to follow, right? The solution process. And we get output, right? Okay, let's try to figure out the three things in here. Okay, so what is the problem here? Yeah, that's the problem, right? Is this number fine or not? That's the problem. All right. So then, what is the input? A number right here. Its particular input is 25. All right. What is the output? Yeah, so it's kind of yes or no kind of answer, right? It's prime or it's not prime. That's the output we expect. All right. What is the process that we are following? Yeah, what is the algorithm?
What we're trying to find out is the 25 can be divided by any number other than 1.
Yeah, that's one. So basically, so to do that, we want to keep dividing starting from 2, right? Until we see something visible by whole number, right? All right. So if you quickly run this one, and you can see that the process plays out, right? So and then get the input, okay, and then that's basically we sometimes use keyboard to enter the number, right? And then the basically if it's a program, CPU does this, right? It runs the program, and then we get the output. Okay. All right. So this process is actually computational thinking, and then there are these are main uh, concepts involving computational thinking. Okay. So decomposition, right? So let's take the so decomposition basically is breaking down the problem into smaller problems or smaller tasks, okay, or simpler problems. Let's take the drawing square problem. Can anyone mention me like tell me a simpler problem in there?
Well, first you have to identify.
Yes.
I was going to say you want to figure out how many turns you might want to do first.
All right. Yes, that's one. Right. Anyone else have ideas?
I was going to say you have to identify what number is used as the input. Is that one of the problems?
We are focusing on the drawing a square.
Oh,
Yeah,
right.
that problem.
Drawing it up.
Yeah.
Right. You're talking about the turtle one?
Yeah, so that's one. Yeah, that's what we're drawing.
What are the problems? Well, first, you
Simple
got,
problems. Yeah.
you gotta make a, you gotta make a plan. You gotta make something that is either up or down.
Okay.
You have to define what it does when it's down. You have to, you have to give it the ability to move.
Okay. Yep. Yep. Yes.
A simple problem would be the domain knowledge required, like the definition of a square, right?
Yeah, that's it. Yeah. Yes. Exactly correct. Yeah. Without the domain knowledge, we don't know what the square is then, right? So, yeah. So this is also a simple step, right? So first, if you want like a step, think of stepwise, then drawing the first side is actually a smaller problem, part of that bigger problem, right? Bigger solution, right? Yeah. So that's that. So all of these things, four steps involving operational thinking. Like next one, right? So focus on this uh, problem, right? Pattern recognition. Well, let's stick with the square one. All right. So pattern recognition means basically many coding problems when we solve. Sometimes there's a pattern occurs and it repeats, and then we actually take advantage of that. So recognizing that pattern is really important. So in particular, to drawing a square problem, what's the pattern? Yeah.
The forward 100 and the left.
Okay. Yeah. Yeah. But if you think of more like you're right. Okay. So if you think of more casually, yes, go ahead.
Sorry, this is going back. But you're saying the example of the square and the domain,
Mhm.
the example of the decomposition, the example of the decomposition.
Yeah, 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 yep,
For the numbers.
yeah. So that's correct. Yeah. All right. So here the basically you have an answer.
Oh, yeah, so pattern recognition, I think, would be, so the definition of a square is quadrilateral with equal
Yeah.
angles and also equal sides. So the pattern would be every step you take would be repeat,
Yeah.
repeat, repeat.
Yeah. So basically that's the pattern, right? That we're gonna follow to draw it, right? So basically the pattern of a square, and as simple as that. That's the pattern. So if we recognize that pattern, then we know what to actually draw, actually, right? So that's pattern recognition. And then algorithm is basically the recipe that you um, of your solution, right? In plain English, pretty much. Okay? So and make sure to number it, right? And then like it's like a real world recipe that you follow it from top to bottom. Right? So that's why it's a sequence of instructions, and then I would say it should be in English as well. Yes.
Yeah, so the algorithm would be not draw a square. It would be go forward 100, turn left.
Yeah, those are the things. And then abstraction is basically generalization of a problem so that you basically your solution can apply to many variants of the problem, right? So pretty much I can give you a real world example, right? That if an engineer, right, if someone let's say make a microwave that can only warm pasta, that's useless, right? Because that's not the only food that we can warm, right? So the microwave should be able to warm up any food, right? Not just pasta. That's an example, real world example of abstraction. So basically, it generalizes the concept of the food from particular food to the all food kind, right? So that we can actually warm up any food using a microwave, right? So you can bring up the same idea here as well, right? So for example, if your code only draw, right, a square with 100 pixel length, that's not that useful because we can only draw from that code the square of 100 pixel length, right? You should be able to draw any square of any length, right? So that's the generalization. So whenever you code in computer science, sometimes we actually solve the problem for particular input or particular problem. Then ask yourself, how can I generalize this to um, other contexts of the same problem, right? So not just one specific problem. Yes.
So what you're saying is like somebody was like, hey, wouldn't it be cool if we drew a square on a computer? And somebody was like, well, instead of doing that, I can make turtle mode so you can draw anything.
Um, yeah, but remember I said like say similar context of the problem. Like you don't need to go generalize to the whole scale, right?
Okay.
Yeah. So I would say like if it is like as an example, if I ask you guys to if you are giving me only uh, code that only draw 100 pixels per side, then I would say that's too specific and you cannot use it for drawing any square, right? So it's a little bit more. Uh,
But not all the way, because I mean, 'cause I was just thinking that turtle mode would be the ultimate abstraction of like let us draw two-dimensional things that involve lines.
yeah, I mean, yeah, it's yeah, you can think of that way, yes. All right. So basically, ask yourself whenever, let's say you are done solving the problem, then ask yourself, how can I make this more general? And in Cybook, what they did to facilitate it general. In that example, the term square drawing code. This is the one actual code. This well, yeah, but one specific action did Cyber provide to write the general square. Yeah, so they gave a small box to enter in, right? So we could enter 100 or 50 or whatever, right? So that means that code actually can draw any square. So it's actually a generalized code. All right. All right. So, but later on, starting in week 4, I will expose you guys to a technique called Ampere technique to actually implement this computational thinking in a better way. All right. So let's do let's say number 3. All right. You guys want to give me a solution. Count the number of sums from the previous question. Multiply this number by 101. This number is the sum of the integers between 1 and 100. Is it an algorithm or a decomposition or pattern recognition? Count the number of sums from the previous question. Multiply this number by 101. This number is the sum of the integers between 1 and 100.
Algorithm.
Anyone else?
Decomp.
Alright, I'm gonna try algorithm, okay? Alright, there you go. Yeah, because this kind of step shows layout the steps, right? Yeah. Okay. Alright, so let's go to the next topic. Any question in between? Questions? Alright. Alright, so collaboration is really important thing, especially in computer science. A lot of product coming from teamwork, right? Here also, I encourage you guys to team up, and that's one of the reasons we do the team discussion together, right? particularly very true in computer science and in product wise, right? There are tools also for collaboration. And, there is an option for you guys to do GitHub project in the midterm. So this is actually like a version control. You can collaborate on code using GitHub or Mercurial or SVK. Um, and there are other collaborating software as well. All right, and then also open source software. And a lot of software nowadays are open source, including Facebook, right? They make their lot of code open source. And then many operating systems like Linux, entire web browser, Firefox is open. That means you can go see the code base, and even you can, if you want to, even for you guys, you can actually contribute as well. All right, so it's not just for expert like software engineers. Even beginner student can also contribute to like projects like Firefox. Okay? And we will watch a video in the middle in couple of weeks on that as well. Okay? So, but if you want to ask me, and I can show you how to, okay, how you can contribute, even as a novice. Okay. All right. All right. I think we are basically done for this chapter. Okay. Before we go take our break, any questions? So we basically kind of skimmed all like all the sections in this week, right? But if you go to the next module, we have 17 sections. Okay. So that module, next module or next chapter is a bit of in-depth module, and then you guys will learn about the language the computer speaks, the zeros and ones, right? The machine language, and then the basics of it. Okay, so not the whole of it, but the basics of the language, which is the binary language the computer speaks. Okay? We are going to start from there and then go to Python, which is the higher language. All right, let's take our break. Take 5 minutes or six. Let's say by 12 or 6, come here, and then we're gonna watch a video. Okay. Hello.
And I'm going to do one thing, and it is like people's hands when they start.
Oh, really?
Oh, yeah. It doesn't. That's probably one of the tips. But it is fun. Okay. What's bro, like the dude on the helping David, and like, how like you get this, and then you know what 7 times 7 was, and I was like, maybe you need to back it up a little bit. What's your dog name? You know what's 7 times 7 is?
I know that.
I think you can do it, bro. Like I really want to do it. Because really, the skill is just
Yep.
there's no one which one to multiply.
Yeah. Oh, it's just form, fill up the form or the form.
Yeah, we'll make more. Yeah.
Oh, okay. Yeah. You have my information, right?
Yeah, like we should look at it.
Oh, okay. Yeah, just too many
Okay.
things.
Okay. Thank you so much. But he was like, oh, good conversation. And now he pre-got this. And I was like, what? Why are you doing that? And he said, I'm just trying to get him started. So I was like, yo, when did you get in touch with him? And he was like, I got a 79. I was like, understood. And I was like, how much did you study? I copied up the formulas. He said I could use them on the test, every test, and all those formulas. I think I got a 79. But what do you think? Yeah. I've been watching all this shit on how old are you? I'm fucking feeling for your blood. I'm 32, so I'm telling you, raise your blood. What's happening? You're still alive. I wouldn't be here, but I'd be in the car. Right, like, you're talking about three. I mean, like, you might be right, because we're just doing three. We're doing something. Yeah. We're doing everything. And when you go, dude, just let me sit down with you, bro, and fucking go over it. Yeah, the first chapter of that book is like, you gotta fucking yeah, you know what I mean? Are you gonna spend 100% of your time on reading shit? And so it's like, maybe like right after school time, we're talking about weekend or something. We can just write it on the weekend. I'm talking about fucking 4 or 5 hours, whatever. But even still, dude, like, I got
All right, guys. So this the video that we're gonna watch right now is actually important. I'd say motivation that we all need, especially in coding. Right? Remember, it takes an effort to solve a problem, and then we face bugs, right? Like software bugs. So and it's frustrating. So it requires some grit actually to stick with it and solve the problem, let's say, right? So, and I also keep learning computer science, right? So, many fields, right, involve that. So let's watch this one. Okay, so it's actually we call it the growth mindset. So I just publish it, guys. Could you all refresh the module view? Right. Publish and if you refresh Canvas view, it should appear in your view. Let's watch. So those sometimes you may have seen books like learn Java in 21 days, like 1 week. They're not that you know efficient, or I don't know, not that practical, I would say. All right. Okay, so let's move on to so pretty much we can actually start our team discussion today. But before that, any question? Anyone has questions in the class? Oh, by the way, guys, I actually I have I think I posted the solution, right? So it's not solution, sorry, recording um, to the our recording. So if you missed Tuesday's class, you can watch it over here. And here's how you read it. It's week 1 and day 1. So today is day 2, right? So and likewise, I hope to put the links in this paper. So so if you missed a lecture and basically I'm recording the screen and my voice, right? So you may watch that one. Okay. Let me go over the two other things that you guys need to do in this module.
Oh, what section are you at?
Oh, this is right here in lecture recordings.
Oh,
It's a page. Yeah. And you will see like it in every module. So I plan to put it in every module like that. So yeah. So the other two things. So we're gonna do this one today, right? So today's discussion will help you do the assignment this module, which is this one. Okay. So these are the other two things that you guys need to do in this module, which is submit this one discussion. Some of you already did, and I actually graded everyone who did it already. Um, so pretty much what you need to do is pick your birthday, right? And um, then based on that, pick technology event happening that year, right? Birth year, right? Um, and then you basically write few words about its impact on your life or society as a whole. Okay? Line or two at least. Okay. I have seen many lines. Some have written really good entries as well. And then once you submit your post, your original post, you will see others. So that's how you see everyone. You basically have to, for this particular discussion, you have to make a submission to see what others see. Okay? So take a look at others and then pick at least one classmate and then write a reply. All right? Yes.
We're going to how to make a smoothie project, right?
Yeah, so now I'm talking about not that one, right? I'm talking about this one right now. Okay.
Okay.
This is not a team one. This is your own individual discussion.
Okay.
All right. So yeah. So basically, yeah. So that's that. So you get 8 points for your original post, the first one, and then for the reply post, you get 2 points. Okay. And then if you want to see the rubric, you can click on these three dots, and then show rubric. Okay. And I will lay out the rubric which says the same. Okay. And then when you reply, make it like make it a conversation and take it from there, right? Don't just say like, okay, this and great job, those kind of things, just an acknowledgement, right? So you get 1 point for that. Okay. So to earn 2 points, just make a meaningful discussion. Sorry, reply. Okay. Um,
So that's kind of cool. So for every assignment you get like a rubric where you kind of tell
discussion, every discussion outside. But every assignment also, every assignment in this class should have a rubric. Okay. And I encourage you guys to read through it. Yeah. All right. Yeah. And then this how you, yeah. So this how you actually see the rubric. So I'm gonna go to actually my test student so that you will see also the student mode. So this one, let me see. I'm gonna go to modules, and then this is how you see your grades. Like go over here and grades, check your grades, and then so I didn't grade the test student, but let's say like for example, looks like I have graded this one, right? So you click on this, right? So I think no, not that one. It's actually let me see. Thing. But if I let's say if I graded you guys and uh, gave you some feedback, there's an icon appear on somewhere else, and then you can click on that and then read my comments. Okay, so that's how you read my comments. Okay, so I'll show you actually that I didn't grade the test student because I don't have right. So I'll show you how it shows, but you will see there's a icon by this side like this one, the same icon, and then if you click on that, you can actually read the feedback given to you. Sometimes the feedback coming from through the rubric, or sometimes from your TA or me as well. All right. Um, so let me leave this to mode. So that's the discussion. Oops, that's not good. Okay, so I closed that one because everyone's grade gonna show. All right. So that's all right. So the next assignment is this one. Um, and in this one, so we're gonna actually do a practice of this one today, right? So all you have to do is pick a day-to-day problem that you face every day, let's say, right? And then write the steps. Like first, you write the crude set of steps, and then in the second part, you basically go in detail and then write sub steps. Like for example, this one, go to school, right? So these are the steps one can follow, right? But if you the same, so this is actually kind of more um, summarized version, right? And then this is the detailed version of the same problem, the solution to the same problem, which is go to school. And you can see that there are two steps with sub steps, right? And we're gonna basically follow the same format and the same kind of process in solving today's problem too, right? You can see that their steps are numbered, bullets, 3.1, 3 dot, right? And then 3.1, 3.2, the substeps. Is yeah, yeah, similar idea, same idea, same idea. Yes. So and then you basically you can use document like Microsoft Word, PDF, text to write this, and you already know how to submit the file to an assignment, right? So you basically follow the same manner and submit the file. Okay. So I think couple of students already submitted this one. Okay. So, but we will do a good practice today for this one. Okay. And you can see that you have to make sure it's the same problem in both. Okay. See that? Go to school and then go to school here as well. Do not pick two different problems. Okay. Yeah. And I think also at the end you can see the rubric. Okay. And you can see that please read it and we will use this rubric to grade your submission. Okay. All right. So those are the two things. The rest actually Please submit this survey, as well as the reflection. Okay, so and this will actually make you reflect at the same time. It will also give me feedback as well. Okay? All right. So let's go to today's problem then. Okay. But before that, any questions? Yes.
Yeah. So, we need to do the quiz, the growth mindset.
Yeah, if you didn't answer now, yeah, so
Okay.
you have, yeah,
Or on our own,
yep.
outside of class, and then what was the other one?
This one assignment, the
Oh, yeah,
assignment, yes,
assignment.
yeah,
So both of them, right?
this one, yeah, and
Okay.
then these two things. Yeah. So these are the surveys and the reflection survey. So those two are two surveys actually.
Yeah.
The
So
model
there's
reflection and
three assignments.
yeah.
Oh,
All right. Yeah. Any other? So you had a question also,
uh,
right? That's fine. Yeah. All right. All right. That's it. Yeah. I think with this, remember, we will be repeating what we did Tuesday, guys. And then pretty much many classes we will be repeating that process. So you will keep improving. Like if you had trouble doing that last Tuesday, you will actually improve this one as well. Okay. So be patient and let's get this one done. Okay. So I'm gonna kind of give you an overview a little bit. Okay. Again, so the the two thing you have to do in this one also, first copy paste your algorithm, then embed your algorithm. That's it. No code, okay? So this is like this is code, right? But this is not, guys. Okay, this is not code. Sorry. Right here, this is not code. We call is a code command. So basically, Python ignores this. These are for ourselves for documentation, like documenting the code. And that's why it's actually started with the pound sign. Okay? So your algorithm should start, each step should also start with the pound sign. Okay? So, and then step one dot, and then two dot, and then you have a substep 2.1, 2.2, likewise. Okay? So make sure to use that. And then the submission process is similar to what we did on Tuesday. Okay? So yeah, with that, let's start. Okay, so did I publish this or not yet? Okay, so publish this. Yep. All right, it's published, guys. So refresh your module view. Okay. Refresh your module view and see similar instructions are there to the Tuesdays one. Um, when you click on this one, so please delete this line. Okay, this is code, so we don't need that. Okay. And then you will start like this, right? And step one dot something like that. And then you will write your step like that. Why is your number algorithm? Anyway,
the computer runs on code.
yeah, and comes top to bottom, right? Code. So if you have, I mean, when you follow a recipe, right? You follow the first recipe, the first step, and the second step likewise. So it's good to have numbers. All right. So first read it by yourself. Take 5 minutes. All right. And then pair up. And then we're gonna do it together, okay? Do it together.
So the last one was we get to pick our own problem, and this is
Yes. This yeah. So when you submit the assignment, you get to pick your own. Yep. This one, yes. And in the meantime, I'm gonna take the attendance, guys. Okay.
Cool, and just one more question, we're just doing one set of instructions this time with subsets. So
Yes. Yeah. It will be the